Okay, y'all, it's time for some trigonometric equations. A trigonometric equation is an equation involving trigonometric ratios. For example, 2x plus 1 equals 0 is an algebraic equation, whereas 2 sine x plus 1 is a trigonometric equation. Why? Because we have the trig right there. Now, we're going to do it mostly the exact same way that we'd handle solving any other equation. It's just what happens is one step kind of gets added on at the very end. So for my algebraic method, algebraic is going to be the predominant method that we look at. There's a pretty good write-up on graphical method in your notes, but obviously algebraic tends to be the preferred one, just because with the algebraic, it gives the exact answers. As well, you guys should have your unit circle beside you. So just make sure that you have a unit circle beside you that you can refer to. And then that way you can get all of the solutions. Now, to solve the equation 2x plus 1, what we want to do is we want to isolate the variable. And if we look off to the right there, you see we subtract 1 from both sides. Then we divide both sides by 2. And that gets me to x equals negative 1 over 2. Now let's say we had a trigonometric equation, and kind of the same thing. We have 2 sine x plus 1. So all that we did is instead of the x, we have sine x now. Well, we get to this point right here, which is the point where it starts to deviate, obviously. What I need to do is I need to find out where sine x is equal to negative 1 over 2. Well, how do I do that? I look at the unit circle. And since we're going for sine x is the y values. So we're going to check for where the y values on the unit circle are equal to negative 1 over 2. Looking at my unit circle, which I have beside me, that tells me that in degrees my answer is going to be 210 degrees, or it's going to be 330 degrees. Subsequently, if I wanted these answers in radians, it would be 7 pi by 6 radians, or 11 pi by 6 radians. So we get these two solutions. Now, realistically, most of these will have two solutions if we're working between 0 and 360, which we will talk about after. There's a couple of nuances we're going to talk about going forward from this. But this would be my answer in degrees, and this would be my answer in radians. Now, sometimes you'll be asked for what's called the general solution. And what my general solution is for sine and cos, what we're going to do is we're going to go plus 360 degree n, or plus 2 pi n. And then we're going to say that n is in the set of integers. Now for integers you can use either an I or a z, but that's something for a different time. Now when we see this 360n where n is in the set of integers, well, what is an integer? And my integer is 1, 2, 3, 4, 0, negative 1, negative 2, negative 3, negative 4. So there are those whole numbers that are positive and negative. So by saying 360 degree n, what we're effectively saying right there is every solution, since we have coterminal angles, I can rotate again and again and again. So all we're doing is we're giving all the coterminal solutions. Okay, so this answer, if I wanted the general solution for it, 210 would become 210 degrees plus 360 degrees n. And 330 would become 330 degrees plus 360 degrees n. If I was working in radians, it would be 7 pi by 6 plus 2 pi n, and 11 pi by 6 plus 2 pi n. So what we have is we have just the regular solutions from looking at our unit circle, and then we can have the general solution. Now we're going to get into restricted domains as well, which will add another bit of fun to this party, but for right now, this is pretty good. Now, if we scroll through the notes right here, I've actually talked about a lot of the things that they're referring to right there, and anything that I haven't directly talked about, I will get to later on in the notes. There is one thing that I do want to bring up though. For the sine and cosines, it's 2 pi or 360 degrees. If you're using tangent, it's going to be pi or rather 180 degrees for when you're stating the general solutions. And this is because of something called period that we'll talk about in the next unit. But for you guys right now, period, we can just say it's the time to repeat itself. So for sine and cosine, it takes 360 degrees or one full rotation for the answers to start repeating themselves. For tan, it takes half a rotation. Again, I will get to that in depth in the next unit and explain what period means. But for right now, you guys are good with just adding the 360 or the 2 pi n. Okay. So we're going to get into the internal rotation and solving all of that stuff next. Have a great day, guys.